Science 20s. Well, welcome to our next lesson. Just going to continue on with stuff that you should know from last year in Science 10, and that would be how to draw some of these diagrams of elements and what have you. And that's going to be very important for us. Basically, since all matter is made up of atoms, and atoms determine the physical and chemical properties of each substance, when we know things like how many protons, neutrons, and electrons there are, how they interact with each other, and what the structure of the atoms within the substance are, it helps us understand the unique properties of various materials and substances that we come across. So let's jump over this practice and jump right into doing the diagrams. Now, to make a quick and easy sketch of a diagram, it's really straightforward. You just got to determine the number of protons, the number of electrons, and the number of neutrons. Now, we often are going to use the Bohr diagram. That's by Niels Bohr. He was the one that came up with the idea that we have all the protons and neutrons in the nucleus, and then electrons orbiting in fixed orbitals. Now, that goes against what the electron cloud model suggests, but we use it, especially in high school, to help us really understand the basics of atoms. And then the electron cloud model just kind of adds a few layers to it to help us out. But we're just going to focus on Bohr right now. So he developed an idea that a certain number of electrons are going to be able to occupy a single energy level. The ones that are closest to the nucleus are going to have the lowest amount of energy, and the further out we get, the more energy they get. Each energy level holds a specific number of electrons. And you can figure that out by looking at the period or the row on the periodic table. So, for example, hydrogen and helium are on the first period. There's only two of them in that first period, and lo and behold, we only have two electrons in the first electron level. If you go down a period, starting with lithium, counting all the elements all the way across, we have 8 elements. Well, it just so happens we have 8 electrons in that second level, 8 electrons in the third level, 18 in the fourth, and so on and so on. So what we do is we fill up the energy levels that are closest to the nucleus first, and then we work our way out. So let's talk about how we would do this. So to sketch a Bohr diagram for an atom of any particular element, we need to use the atomic number and the atomic mass. Now, the atomic number, as a reminder, tells us the number of protons. Using the mass number, we subtract the proton number to give us the number of neutrons. We also have to take that mass number. If it's the atomic mass, we have to round it to the nearest whole number. And then finally, the number of electrons in an atom will always equal the number of protons. Once we've done that, we will draw the nucleus of the atom, put in the appropriate number of protons and neutrons, and then we will start to fill up the electrons in each energy level. So, for example, let's start with one element that we always need in abundance, and that would be the element of oxygen. So let me just switch over to the pen here, and we can start looking at how we would do oxygen here. So O is the symbol for oxygen. We know that its atomic number is 8, which means there are 8 protons, and its mass number is 16.00, and that's the number of protons plus the number of neutrons. This is one of the reasons why I like doing oxygen, is because on most periodic tables, it's not exactly 16.00, but the average is rounded to 16.00. So it makes the rounding a little bit nicer. And from that, we then determine that there are 16 minus 8, or 8 neutrons. I'm just going to switch over to a different color here. And then I'll put this into our diagram. So what we would do is you would draw your nucleus first, and then you're going to put in the atomic number, which is going to be 8. And then you put in the neutron number, which we use which we find by using the mass number. And then we start to put in the electrons. Now, some people will just spread the electrons all out around. I like doing it a slightly different way. I'm okay doing it that way for the first shell because it's pretty much everybody has a full innermost shell. The only one that doesn't is hydrogen, and it just has the one electron floating around in there. So, and then what I like to do, and when we do Lewis dot diagrams in a moment, this will make a little bit more sense. Some people will take these 6 electrons and they'll spread them out evenly. They'll put one here and one here and one here, and etc. I like doing it this way, where I put my second one here, my third one here, my fourth one here, and then my 5th and my 6th electrons get paired up. Okay, we'll explain this in more detail in the lessons to come here. But anyways, that's how you would do oxygen. Now, there is sort of a shorthand or a shortcut way of doing it, and that is by drawing the nucleus, again, with proton numbers and neutron numbers. And then we put the electrons just on a line going above as we move out. So let's down here, just for fun, let's repeat this diagram. So I'm going to put in 8 protons. I'll put in 8 neutrons. But instead of drawing all the rings all the way around, I'm going to draw a line representing the first orbital. And we know it's full, so we put in 2 electrons. And then I'm going to draw a line. So in the next orbital, we have 6 electrons left over. Now, I forgot to mention that if we have 8 protons for the atom, we're also going to have 8 electrons. 2 electrons go into the first orbital. That gives us 6 electrons left. So let me just change into red here. So that means we'll take and fill the 2 in here first, and then the 6 that are left over. Since it's not a full 8, we can put a full 8 in there, but it's not 8, so we'll put them in that way. Anyways, that's how you would do the sort of shorthand energy level diagram. Not the Bohr level, but an energy level diagram. So if you're given an energy level diagram, you got to be able to tell us what element it is. Here's the easiest way to do it. What we do is we look at the proton number. Whatever the proton number is, will tell you where on the periodic table it is, what the atomic number is, and that's going to give you the type of element that we have here. So in this case, we're dealing with 6 protons, and that's going to have carbon. Okay. Now, Lewis dot diagrams take it even a little bit more simply in the fact that we don't have to worry about putting in a number of protons or neutrons. We don't even have to worry about the inner shells of electrons. All we're worried about are the electrons that are in the outermost shell. This is what we call valence electrons, and valence electrons are very important in chemistry. So we do the Lewis dot diagram as follows. And I like starting off doing first nitrogen, or first carbon, and then nitrogen, and then oxygen to show it off. So you put the symbol here in the middle, and then you just put your electrons. I like to call it going around the block. So you start here, we put one there, one there, one. Okay, so we've got our 4 electrons for carbon. Some people say you put it on the 4 compass directions, so north, east, south, west. But here's the important thing. When you're drawing the diagram, so let's do nitrogen. When you're drawing the diagram, this is how I like to do it. I always like starting out on the top, and I put in my first, and then I just start working around the letter there. So 4 out of the 5 electrons, 1 in each of the 4 direction spaces. So top, right, bottom, and left. And then we have 1 electron still to place. I'm going to just keep going around the block. So I started here. I'm going here, here, here. Now I put my 5th one up here. So we have these 2 electrons down. Now these 2 electrons that are here are what we call a lone pair. And we'll get into the significance of lone pairs in more detail in future lessons. But that's how you would draw it. Now, oxygen, I like doing oxygen because oxygen, we end up with having two lone pairs. I'm just going to change color here. So oxygen has 8 protons, like we showed before in our energy level diagram and in our Bohr diagram, 6 valent electrons. So I'm going to put 1 here, 2, I'm going around the block, 3, 4, and then I keep going, 5, 6. Now, some people say, well, why don't we just put 2 up here and 2 down there? And they kind of, repel it. No. This is a more accurate way of showing what actually happens with the shape of the atom and where these valence electrons are. But yeah, that's basically what we would be looking at for doing oxygen. Okay, so I've given you the rules that you need to be following. So in the meantime, again, here these are the instructions, so you can read over those on your own. Let's just do one of these together. Let's do fluorine. Fluorine is nice. I mean, not that I would, suggest inhaling it or anything, but it's a nice, fun little element. Now, I want to show you the periodic table, and I want to show you something interesting here. You see these group numbers, right? Group numbers are the columns or at the top. So we have group 1, we have group 2, 3 through 12. We're just going to kind of skip over a little bit. Group 13, 14, 15, 16, 17, and 18. Now, here's what I find interesting about this. We really, when it comes to the periodic table, we really only concern ourselves with the first 3 periods. At least in high school, we look at the first 3. You could follow some patterns for group 1 and 2. A similar but few subtle but necessary differences in group 18. But here's the thing. In our first column, we have hydrogen. Hydrogen has 1 valent electron. Lithium has 1 valent electron. Sodium has 1 valent electron. Everybody in group 1 has 1 valent electron. Over in group 2, beryllium has 2, magnesium has 2, calcium has 2. Guess what? They all have 2 valent electrons. Now we're skipping over all of these guys because they don't. Groups 3 through 12 do not have any elements in the first 3 periods. When we get to boron, boron is number 13. Last digit is 3. Well, guess what? Boron will have 3 valent electrons. Carbon in group 14 has 4 valent electrons. We've already done nitrogen and oxygen, but they're in groups 15 and 16. Fluorine is in group 17, so it's going to have 7 valent electrons. So let's do this. So we know the number of electrons in the atom is going to equal 7. So that means I'm going to start up here. 1, 2, 3, 4, 5, 6, 7. I just keep going around the block. Some people like having that 1 lone electron at the bottom, and so they'll actually start here. They'll go 1, 2, 3, 4, 5, 6, 7, and then leave the single electron at the bottom. Honestly, it really doesn't matter for fluorine because you're going to have the rest of the 3 be lone pairs, just 1 valent electron. Okay, well, that's all that I got for you on this video today. So do the practice, do the homework that you're given. Go back and do those other 2 elements that I didn't do for you that were in the slides. And once you have that done, you can proceed on to the next video. We'll see you there.